Now we will see industrial production of hydrogen, the Bosch process. Karl Bosch, a German chemist, invented a Bosch process for preparing hydrogen on a manufacturing scale by passing a mixture of steam and water gas over a suitable catalyst at high temperature. Hydrogen is an important ingredient in many industrial processes. For large-scale production of hydrogen, the Bosch process is used. Step 1. Production of water gas. Water gas is a mixture of carbon monoxide and hydrogen. Water superheated steam is made to react with carbon red hot coke at a high temperature of 1000 degrees Celsius and above to form water gas. The reaction is endothermic. Step 2. Reduction of steam to hydrogen by carbon monoxide. Hydrogen and carbon monoxide mixture is difficult to separate. Therefore, in this step, CO is converted into CO2 by reacting the water gas mixture with the equal volume of steam in the presence of catalyst iron oxide Fe2O3 and steam promoters like chromium oxide Cr2O3 at 450 degrees Celsius. The reaction is exothermic. Carbon monoxide is oxidized to carbon dioxide with the production of more hydrogen. A promoter is a substance that increases the efficiency of a catalyst. Step 3. Separation of hydrogen gas from the mixture. The mixture is passed through water under pressure approx 30 atmospheres. Carbon dioxide dissolves in water and hydrogen is collected in cylinders. The produced hydrogen is refined to desired levels of purity by other chemical methods. Now we will see properties of hydrogen. First, we will see physical properties. First, hydrogen is a colorless, odorless, tasteless and non-poisonous gas. Second, it is the lightest element. Its density is 0.09 gram per decimeter cube. Third, it is insoluble in water. 1 liter of water dissolves 20 milliliter of gas at normal room temperature and pressure. Fourth, it is the best conductor of heat among all gases. Fifth, the melting point of hydrogen is minus 259 degrees Celsius and its boiling point is minus 253 degrees Celsius. Sixth, hydrogen is a highly inflammable gas and burns with a pop sound. Did you know liquefied hydrogen is extremely cold and it can cause severe frostbite when it comes into contact with the skin? Now we will see chemical properties. First, litmus paper. Hydrogen is neutral to litmus paper. That is, it neither changes blue litmus paper to red nor red litmus paper to blue. Second, combustion. Hydrogen is a combustible gas, which means it burns itself. It does not support combustion. Pure hydrogen burns silently with a pale blue flame, but a mixture of hydrogen and air burns with a characteristic pop sound. Third, reaction with active metals. Hydrogen reacts with active metals like sodium, potassium and calcium to form the corresponding metal hydrides. Now we will see reaction with non-metals. Reaction with nitrogen. Hydrogen combines with nitrogen gas at a temperature of about 450 degrees Celsius and high pressure of about 200 atmospheres with iron as a catalyst and molybdenum as a promoter to form ammonia gas. This reaction is reversible and exothermic. Nitrogen gas reacts with hydrogen gas to form ammonia gas, and 2 plus 3H2 gives 2NH3. Now we will see reaction with oxygen. Hydrogen burns in the air with a pale blue flame or reacts with oxygen present in the air to form steam, which condenses to form water. Hydrogen reacts with oxygen to form water. 2H2 plus O2 gives 2H2O. Now we will see reaction with sulfur. When hydrogen gas is bubbled through molten sulfur, it forms colorless hydrogen sulfide gas which smells like a rotten egg. Hydrogen plus sulfur gives hydrogen sulfide. H2 plus S8 gives H2S. Next we will see reaction with chlorine. Hydrogen combines with chlorine gas in the presence of diffused sunlight to form a hydrogen chloride gas. In the bright sunlight, the reaction is very explosive and produces a lot of energy. In the dark, no reaction occurs. Hydrogen plus chlorine gives hydrogen chloride gas. H2 plus Cl2 gives 2HCl. Hydrogen chloride gas is highly soluble in water. It mixes with atmospheric vapors to form a mist which appears as white fumes. It dissolves in water to form hydrochloric acid. Now we will see reaction with metallic oxides. When hydrogen is passed over heated metallic oxide, it removes oxygen from the metallic oxides to form metal and water. For example, iron oxide reacts with hydrogen to form iron and water. Fe2O3 plus 3H2 gives 2Fe plus 3H2O. When hydrogen is passed over heated copper oxide, the black compound turns reddish brown. Copper oxide plus hydrogen gives copper and water. CuO plus H2 gives Cu plus H2O. When oxygen is removed by a substance from a compound, we say that the compound is reduced. This process is called reduction and the substance is called reducing agent. Hydrogen can remove oxygen from metallic oxides, therefore hydrogen is called a reducing agent. Now we will see oxidation and reduction. The process of adding oxygen or removing hydrogen is known as oxidation, whereas adding hydrogen or removing oxygen is known as reduction. Now we will see oxidizing and reducing agents. The substance which gives oxygen or removes hydrogen is known as an oxidizing agent, and the substance which gives hydrogen or removes oxygen is known as a reducing agent. Now we will see redox reaction. Oxidation is the reverse of reduction. A reaction in which oxidation and reduction take place simultaneously is known as a redox reaction. The reaction between lead oxide and hydrogen is a redox reaction. Lead oxide, yellow, oxidizing agent plus hydrogen reducing agent gives lead red-brown reduced substance and water oxidized substance. In this reaction, hydrogen is the reducing agent and lead oxide is the oxidizing agent because it gives oxygen. Lead oxide is reduced to lead and hydrogen is oxidized to form water. Now we will see reaction of hydrogen with carbon dioxide. Hydrogen combines with carbon dioxide at a temperature of 300 to 400 degrees Celsius under high pressure with nickel as a catalyst to produce methane and water. Now we will see reaction of hydrogen with carbon. Hydrogen combines with carbon and forms compounds called hydrocarbons. The reaction occurs at temperature above 520 degrees Celsius with nickel or cobalt as a catalyst. When the temperature is further raised, the reaction is reversed. Now we will see uses of hydrogen. First, hydrogen is used in the manufacture of ammonia NH3, which is further used for making fertilizers. Second, when a mixture of hydrogen and oxygen is burnt, it gives very hot flame of about 2800 degrees Celsius. This flame is known as oxyhydrogen flame and is used for cutting and welding metals. Third, hydrogen being the lightest element was used to filling air balloons for the meteorological purposes. Due to high inflammability of hydrogen, the weather forecasting balloons are filled with hydrogen and helium. Fourth, vegetable oils such as palm oil and groundnut oil are liquid at room temperature. Hydrogen is used to harden vegetable oil into vegetable ghee in the presence of nickel as a catalyst. This process is called hydrogenation of oils. Thank you.